It's 4:17 in the morning, and you're awoken by a loud rumble. Your house is shaking violently from side to side. You quickly realize this is an earthquake and you need to get to safety. Where do you go? How do you protect yourself? And what caused this natural disaster in the first place? Let's start at the beginning. Earthquakes are caused by the sudden release of energy in the Earth's crust, which creates seismic waves that shake the ground. Most earthquakes happen along fault lines, which are fractures in the crust where large slabs of rock called tectonic plates meet. Although the plates are always moving, very slowly, a few centimeters per year, the movement isn't smooth. Friction and resistance from the rocks along the fault cause the plates to build up stress at their edges. But the rocks have a breaking point. When the stress exceeds the strength of the rocks, the fault slips suddenly, releasing the stored energy in the form of seismic waves that travel through the Earth's layers, causing the ground to shake. This process happens really fast, within a fraction of a second. The point beneath the Earth's surface where the slip begins is called the focus, or hypocenter, of the earthquake. The point directly above it on the Earth's surface is the epicenter. The amount of energy released during an earthquake is measured using a seismograph, which records the strength of the earthquake at its source. The energy is then transformed into a magnitude, which is a unitless number. The magnitude of an earthquake is a logarithmic value. So each whole number increase represents a tenfold increase in amplitude. For example, a magnitude 5 earthquake is 10 times stronger than a magnitude 4 earthquake. The depth of the focus determines the intensity and duration of an earthquake. Shallow focus earthquakes are more intense but shorter in duration, whereas deep focus earthquakes are less intense but may last longer. The geological characteristics of the region also play a role. For example, soft soil can amplify the shaking of an earthquake, making it more destructive. Earthquakes are most common near active plate boundaries, such as the Pacific Ring of Fire, where the Pacific plate is being subducted or pulled beneath the edge of another plate. Other regions with high earthquake activity include areas where plates are colliding, such as the Himalayas, or where plates are pulling apart, such as East Africa. The San Andreas Fault in California is a transform boundary where two plates slide horizontally past one another. Most of the major cities in California are located near the fault, so there is always a risk of a major earthquake in the region. In fact, the San Andreas Fault is considered to be one of the most dangerous faults in the world. One of the most devastating earthquakes in history occurred in 1556 in Shanxi, China. It had an estimated magnitude of 8.2 and a maximum Mercalli intensity of 12. According to historical records, the earthquake lasted about 10 minutes, and it affected an area of about 83,000 square kilometers. It's thought that about 830,000 people lost their lives due to building collapses and subsequent landslides. In 1960, an earthquake with a magnitude of 9.5 struck Chile, causing widespread damage and a tsunami that affected coastal communities. This event, known as the Valdivia earthquake, was the most powerful earthquake ever recorded. In recent years, Turkey has experienced several major earthquakes, including a 7.8 magnitude earthquake that struck in February 2023. The earthquake caused widespread damage and loss of life. The country's emergency response team has been working around the clock to rescue people from the rubble. The worst earthquake to hit the United States was the 9.2 magnitude North American earthquake of 1776, which struck near Cape Mendocino, California. It caused significant damage in California and as far away as New York. Fortunately, the population density was low in the 18th century and most of the damage was to property. But if an earthquake of similar magnitude were to strike today, the economic impact would be catastrophic. Although we can't predict when an earthquake will occur, scientists use various methods to estimate the probability of an earthquake happening in a particular area over a specific period. One method is to study the history of earthquakes in the region, which can provide insights into the recurrence interval and magnitude of future events. By analyzing historical data and instrumental records, Scientists can develop probabilistic forecasts for earthquake occurrence, which inform building codes and land use planning. Another method is to monitor seismic activity in the region using networks of local and regional seismometers. By recording the time, location, and magnitude of small earthquakes, scientists can identify areas that may be at risk of larger events. Additionally, researchers are exploring new technologies such as artificial intelligence and machine learning to analyze vast amounts of data and improve earthquake forecasting. Despite these efforts, predicting the exact timing of an earthquake remains a significant challenge, and it's impossible to say with certainty when the next big one will strike. However, by understanding the risks and taking appropriate precautions, we can better protect ourselves and our communities.